In this problem, we've been given the graph of a rational function. What we'll do is we'll gather information about that function and then use that information to figure out what the original function was. Let's begin by looking for the asymptotes. First, we'll start with the vertical asymptote. We can see there is a split in this function here at -2 where I'm drawing the dotted red line now. We can see to the left of -2, we're running upward toward positive infinity, but on the other side of that asymptote, we're coming back in from negative infinity. The dividing line is at x equals -2, so I'll write that down as my vertical asymptote. You may be able to see we have a horizontal asymptote as well, which I'll draw in another red line going from left to right. This horizontal red line looks like it's about halfway between 0 and 2, so we'll mark that as 1, and we'll say our horizontal asymptote is y equals 1. Keeping in mind we say y equals 1 because it crosses through the y-axis at 1. We'll also mark our intercepts. I'm going to mark in green where the x-intercept is. It's about halfway between 0 and 2, and so we'll say that's at 1, 0, where x is 1 and y is 0. We also have a y-intercept. Notice that this is about a quarter of the way between 0 and -2. Halfway between 0 and -2 would be -1, and so halfway to -1 is -1/2. Therefore, we'll say the y-intercept is 0, -1/2. X-coordinate of 0, y-coordinate of -1/2. Now to mark our holes. The hole may be fairly difficult to define exactly. We can see from the mark on this graph that our hole is at 2, undefined. It's going to be difficult to get a y value just based on this graph, so we'll try to approximate as best we can. We might notice that this hole is a little bit lower than a half, so we'll approximate that as about 1/3. This may not be perfect right now, but we'll write down what we know for now. We'll say the hole is at 2, about 1/3. I'll put the little squiggly marks to show that it's fairly close to 1/3. If we get something a little bit different, that's okay. Now we'll write the domain. The domain is the number line that is split by the holes and vertical asymptotes. We'll draw our number line, and we'll put open circles at both the vertical asymptote and the hole. Our hole was at an x-coordinate of 2, and our asymptote was an x-coordinate of -2. That will split the domain into 3 pieces. Piece A will go from -infinity to -2, piece B from -2 to 2, and piece C from 2 to positive infinity. Therefore, our domain will be -infinity to -2 union -2 to 2 union 2 to infinity. Now that we have the asymptotes, intercepts, holes, and the domain, we can use that information to try to figure out the original function. First, we'll look to the hole. Any holes we have in the graph will end up in both the top and the bottom of our rational function. You may remember from a previous video that in order to find the location of a hole from a rational function, we had to factor the top and bottom and try to cancel terms out. Here we'll go the other way and say wherever our hole is, that will appear on the top and bottom. Therefore, we're going to start from the x-coordinate of our hole, which is 2, and we'll say x must equal 2 for the hole. But now we'll take the 2 and move that to the other side of the equal sign. This will give us x minus 2 equals 0. The x minus 2 must go on the top and the bottom of our rational function. Therefore, lower down on the slide, I'm going to write that whatever our rational function is, it must have x minus 2 on both the top and the bottom. We can do the same thing with our x-intercept, but the x-intercept will only appear on the top. Our x-intercept was 1, 0, so I'll say x equals 1, but once again move the 1 over to the other side and end up with x minus 1 equals 0. This will go to the top, and so we will place it only on the top. We can do the same thing for the vertical asymptotes. However, the vertical asymptote appears only on the bottom. Our vertical asymptote says x equals -2, so now, once again, we take the number on the right, -2, move it to the left, and we'll end up with x plus 2 equals 0. This x plus 2 will go to the bottom. Now we've done most of the work, but there's one piece of information that we have not dealt with. That's the leading coefficient, which I'm going to call a. We're going to have to use one other piece of information to solve for a. We've looked at the holes, the x-intercept, and the vertical asymptotes. We can use either the horizontal asymptote or the y-intercept to figure out the value of a. We'll talk about ways you can find a on the next slide. The usual way that we find a is by using the y-intercept. The y-intercept says 0, -1/2 is on this graph. Therefore, we can say that when x is 0, y is -1/2. We're going to let, then, x equal 0 and y equal -1/2 and see what a is. In place of y, we will say -1/2, and in place of x, we will say 0. We can begin after plugging in 0 by canceling out 0 minus 2 on the top and the bottom. This will give us -1/2 equals a times -1/2. If we multiply on both sides by the reciprocal of this number next to a, that's the -1/2, we'll say times -2/1 on the right and times -2/1 on the left. Remembering that if there is a fraction next to our a, we can multiply by its reciprocal to cancel. This will cancel out the fractions on the right, because -1/2 times its own reciprocal cancels out and gives us 1a. However, on the left, we have the same thing. The -2/1 cancels out with the -1/2. If you want to verify this by checking in a calculator, you can enter that multiplication and it will give you 1. Therefore, a is equal to 1, and our rational function will be y equals 1 times x minus 2 times x minus 1 over x minus 2x plus 2. You can do this anytime your y-intercept is not 0, 0. If your y-intercept was 0, 0, you would have to find another point on the graph other than the y-intercept, and plug that in instead. Thank you for watching. We'll see you again soon.